So we're going to do the same process as we did in the previous video. If you haven't seen the previous video, I would recommend that you watch it. But I'm going to do the 4 diagrams with the algebra and the computer programming for all of the OR gates. So there's my first one, A, B and Q, which I think we've already done, probably not. Yeah, we've done OR gates, just checking. So in algebra this would look like Q equals A or B, and in programming we would just have A or B. The second one is where I'm going to insert the NOT gate on the first input. Remember, this is an OR gate, and this would look like Q equals not A or B, and programming would be not A or B. Third one is where I put it on the B gate and leave the A gate alone. So there's my inverter OR symbol, Q, A, B, and this one would be Q equals A or not B. And again, the programming is A or not B. And finally, where I have an inverter on both inputs. So they're the only 4 possible combinations I could have on the input. Don't forget it's an OR gate, A and B, and that gives me my Q equals not A or not B. And written out is not A or not B. So they're the 4 gates as we did before. So I'm going to have the truth table. So the quickest one was the straightforward OR. Just going to dash through this. You should be okay with this now from watching the previous videos. And I'm going to mark the results in red this time. I haven't done it in black before. So anywhere for an OR gate, any one that is 1 produces a 1 in the output. So that is the only one that will produce a 0. Everything else has got a 1. Okay. So that is A or B. And if you remember, we can, instead of putting Q, we could just write what the actual thing we're working on is. This one's going to be A or B. I'm just leaving a bit of a gap there because I'm going to do the not A. So A was 0, 1, 0, 1. B was 0, 0, 1, 1. Not A, exactly the same as before. That's going to be a 1, that's going to be a 0, that's going to be a 1, that's going to be a 0. And the output's going to be 1 if either one of these two is 1. And we're doing not A or B. So that's a 1, a 0, a 1, a 1. Moving on. Quickly, on this one, we have got a straightforward A. We're not going to invert it. Then we've got a B and a not B. So I'm just going to put the not B there to help me. So, oops, A was 0, 1, 0, 1. It's easy to get lost in these, so don't worry if you find yourself having to practice a lot. So my not B is going to be 1, 1, 0, 0. And now I've got to do my result. It's an OR, so any one that is 1. So I'm looking at this column and this column here. That's got a 1 in it. Let's go red. That's got a 1 in it. That's got a 1 in it. Oops, yep. See, even I make mistakes. I'm not looking at this column, I'm looking at 0 and 0. So that's got a 1 in it, that's got a 1 in it, and the bottom one has got a 1 in it. Those two are 0. So easy to make mistakes. And finally, we're looking at this one where we're doing not A or not B. So A and B, then I'm going to have my not A, not B, and Q. A is going to be 0, 1, 0, 1, 0, 0, 1, 1. Let's get these not A's in. So that is going to be 1, 0, 1, 0. And that is going to be 1, 1, 0, 0. And this time all I am doing is looking at these two columns here. Anyone with a 1 produces a 1. And that's the truth table for not A or not B. Now if you take a look at all the truth tables together, you'll see that they're completely different patterns. Okay, they're unique, each one. So that could help us prove what we've got when we're playing around with programming or algebra. If we look back at the truth tables for what we've got, then we can say which one of these it was. And that probably hasn't made a great deal of sense to you. Hopefully it will do soon. So we're left with just one more to do, which is the not. So I'm going to do it on here. To be honest, I'm going to do my not gate because it's fairly trivial. If I've got 2 of them, then I've just got another not gate. So if I put a 0 in here, 1 comes out here because it's knotted it. If I put a 1 in there, a 0 comes out there. And if I put a 1 in here, it's going to invert it, so a 0 comes out there, and not again, invert it again, a 1's going to come. What happens is that nothing changes. So this is so trivial, it's not even used, and I would be gobsmacked if this appeared on any paper. It's a basic trick. So it leaves it unchanged. Nothing happens. So we can forget that not gate. So what I want to look at now is a question that was brought up in the class about brackets. And we need to think carefully about this because this is where Boolean algebra is going to be a little bit different from regular algebra, particularly with brackets.